Susu Zangpola, Bhutan e-learning project welcomes children to this lesson. I am Karpa Yangden, teacher of Changsamto Middle Secondary School. This is a lesson on physics for stage 4, classes 9 and 10. In this lesson, we will learn about electromagnetic spectrum, study its characteristics and uses, and we will also learn about satellite communication and communication through waves. These are the lesson objectives. On completion of this topic, students should be able to identify different components of electromagnetic spectrum, identify electromagnetic waves, state some uses of electromagnetic waves, and finally explain the communication through waves and satellite communication. To start with the lesson, I brought a bucket full of water. Let's see what happens if I drop this stone in this water. Yes, you can see a ring of ripples grow outward in a concentric circle. This is known as water wave. So, wave is defined as the disturbances that travels through the medium in the form of energy. Or in simple, you can define wave as to and for motion from one place to another. There are two types of waves, mechanical waves and electromagnetic waves. Mechanical waves are the waves which requires material medium for its transmission. For example, we have water wave, seismic wave, and finally the sound wave. Electromagnetic waves are the waves which do not require material medium for propagation. For example, we have light wave, X-ray, so on and so forth. Sun is the main source of electromagnetic wave, and all those electromagnetic waves are arranged in their order of frequency and wavelength. And this process of arranging electromagnetic waves in the order of their frequency and wavelength is known as electromagnetic spectrum. This is the image of electromagnetic spectrum. And as stated in the definition for electromagnetic spectrum, these waves are arranged in the order of wavelength and frequency. As you go from left to right, the wavelength, it keeps on decreasing. And in terms of frequency, as you go from left to right, the frequency, it keeps on increasing. So with this, we can see that the wavelength is inversely proportional to the frequency. More the wavelength, lesser will be the frequency. Lesser the wavelength, more will be the frequency. Now, it's very important for you all to remember the sequence of those waves. If you know the sequence of these waves, then you can easily compare the wavelength and frequency of two or more waves. For example, if you are asked to compare the wavelength and frequency of microwave and X-ray, by looking at this sequence, you can directly say that the wavelength of microwave is more compared to the wavelength of X-ray. At the same time, the frequency of microwave is less than the frequency of X-ray. So likewise, using this electromagnetic spectrum, you can compare the wavelength and frequency of all those waves. And one very important thing is frequency and energy is directly proportional. If the wave with more frequency will have more energy, and the wave with less frequency will have less energy. You all have seen that there are 7 electromagnetic waves in the electromagnetic spectrum. We have radio wave, microwave, infrared radiation, visible light, ultraviolet radiation, X-ray, and finally the gamma rays. Now let's learn about these waves individually. We have radio wave with a frequency up to 3 into 10 raised to 10 Hz and wavelength greater than 10 nanometer. This wavelength is well known for their uses in communication like television, radio, and mobile phones. Now let me explain explain how we get to watch BBS 2 and BBS 1 program. The sound and photos produced at the Bhutan Broadcasting Service station is being modulated, meaning it is converted to electromagnetic wave. This wave is fed into the transmitting antenna, which is fixed on the top of tower. This electromagnetic wave travels through a long distance and it finally strikes on the receiving antenna. And this receiving antenna, it contains alternating current which transmits the signal to every individual household through the use of cable. However, if you expose yourself more to the radio wave, it will lead to headache, sleep disorder and some neurological problem. The next wave we have is the microwave, with the frequency 3 into 10 raised to 9 Hz to 3 into 10 raised to 13 Hz. And its wavelength is between 1 meter to 1 millimeter. Microwave is used in heating and cooking foods using microwave ovens. It is also used in satellite communication, and it's also used in Wi-Fi, mobile and other Android phones to transfer data like videos and photos. Okay, now let's explain how the micro oven works. This metal box contains a magnetron, which is a generator to generate microwave. Now let me try to heat this water. As I put in this water and switch on the oven, the magnetron will take in the electricity and it will convert, it will produce enough microwave. These water molecules or any other molecules, the molecules of any other substance that we heat in the oven, it will take enough microwave and the molecules will start vibrating. Hence, it will produce enough heat, and that's how the foods and other stuffs get heated. However, if you expose yourself more to the microwave, it will burn your internal tissue, which may result in cancer. The next wave we have is the infrared radiation, with the frequency 3 into 10 raised to 13 Hz and 4 into 10 raised to 14 Hz. And the wavelength 10 raised to negative 4 meter to 7.8 into 10 raised to negative 7 meter. This infrared radiation is used in television remote. In order to change the channel, in order to increase or decrease the volume and power off and power on the television, we use remote control. And between this television and remote control, the infrared radiation plays a very important role. It is also used in security system and in optical fiber to transmit information. But if you expose yourself more to the infrared radiation, then it may cause cataract and it may also cause skin burns. So do not expose yourself to infrared radiation for longer duration. The next wave we have is the visible light, which lies in the middle of electromagnetic spectrum. The visible light is the only wave which can be seen with our naked eyes. The visible light consists of 7 different colors: red, orange, yellow, green, blue, indigo, and finally violet. It has the frequency of 4 into 10 raised to 14 Hz to 48 into 10 raised to 14 Hz, and the wavelength lies between 7.8 into 10 raised to negative 7 meter to 3.8 into 10 raised to negative 7 meter. Visible light is mostly used in photography and electric bulb in our home. But exposing yourself more to the visible light may damage your eyes. Therefore, you should not look directly to the sun. The electromagnetic spectrum, which lies beyond the violet end of visible light, is called ultraviolet radiation. The frequency of ultraviolet radiation ranges from 8 into 10 raised to 14 Hz to 3 into 10 raised to 16 Hz. and it has the wavelength 3.8 into 10 raised to negative 7 meter to 1.0 times 10 raised to negative 8 meter. It is used to detect the forged documents, used in construction and factories to detect the defects. It is also used in forensics. Exposing more to ultraviolet radiation may cause suppression of immune system. It will also cause eye cancer and premature aging. This is a German physicist, William Röntgen. In 1895, he discovered a unique radiation. He found out that this radiation can penetrate through the soft tissues and skin. And he was not sure what kind of radiation it was. So he named it as X radiation, and later it was called X-ray. The frequency of X-ray ranges between 3 into 10 raised to 16 Hz to 10 raised to 18 Hz. It has a wavelength from 10 raised to negative 8 meter to 10 raised to negative 10 meter. There are two types of X-rays, hard X-ray and soft X-ray. It is used in hospitals for medical diagnosis and in airport security for scanning the bags, and it is also used in some of the gates to scan the bag that we carry with us. For example, when we go to visit a Shichezon, on our way, we are asked to scan the bag that we carry with us. So while scanning that bag, X-ray is used. If you are more exposed to the X-ray, then it will cause damage to the cell, causing mutation and dead cells, which may further lead to cancer. Therefore, we should not expose ourselves more to the X-ray. The last electromagnetic wave in the electromagnetic spectrum is the gamma rays. It has the frequency greater than 10 raised to 18 Hz and the wavelength lesser than 10 raised to negative 10 meter. It occupies the same range of electromagnetic spectrum as that of hard X-ray. But the only difference between these two are their source. The gamma rays is produced by the radioactive nuclei, whereas the X-ray is produced by the accelerating electron. The gamma rays is used to sterilize the equipment, medical equipment and any other equipment that needs sterilization. The second use is, since the gamma ray is at the extreme right, you have already seen that the gamma rays lie at the extreme right. So as we move from left to right, the frequency it keeps on increasing. So towards the extreme right, the frequency is higher. So compared to other electromagnetic wave, the gamma ray has the highest frequency. So more the frequency, more will be the energy. So gamma rays overall, among the electromagnetic wave, gamma ray has the highest frequency and the most energy. So since it has the most energy, it will have high penetrating power, due to which it is used for curing cancer and even it is used in chemotherapy also. If you get more exposed to the gamma rays, then the effect is same as that of X-ray. But compared to X-ray, since the gamma ray has more energy, the effect will be bit severe than the X-ray, which means it may damage our cell, which causes cancer. Because of this, you might have seen that some of the health workers, they wear lead coat, lead aprons, or sometimes they hide behind the lead in order to save themselves, protect themselves from the gamma rays and X-rays. Did you understand the different types of waves? Great! The next topic we have is the communication through waves. Now, do you know how the communication is done in olden days? This is a goodness movie. In this movie, the father gets very much excited to receive a letter from his son. Along with the letter, he also receives a photo of his son where he gets very much excited. This is how the communication in olden days are done. There used to be a messenger who collects the message and letters from one place, and it takes around 2 to 3 days and sometimes a week to reach the message to other part of the country. This was made easier for the messenger to deliver the message and letters with introduction of horse transportation. The communications was made faster with introduction of post office, telephones and telegrams. These days, messages and informations are sent in the form of electrical signal with high frequency wave carrier like radio wave and microwave. So as the electromagnetic wave travels, it interacts with many objects and media, due to which it gets refracted, diffracted and reflected. Now let's see how diffraction and reflection of waves takes place. This is the diffraction of wave. So most of the time, diffraction of wave plays a very important role to transmit signal from one place to another. Because when the wave undergoes diffraction, it will be able to reach the places which are not accessible to the signal. For example, the diffraction region. This region is not accessible directly to this signal. However, when it undergoes diffraction after striking this medium in between, the wave gets diffracted, and that's how the signal reaches the area where it is not accessible to the signal. So that's why the diffraction of wave is very important in order to transmit signal from one place to another. Now one thing is, there are 7 waves in total, isn't it? So among those 7 waves, only microwave and radio waves are used. Because compared to other waves, these 2 waves, microwave and radio wave, will undergo diffraction, reflection and refraction. Because of this reason, microwave and radio waves are used for communication. So this is the reflection of wave. The signal from this tower, the antenna of this tower, it strikes on this obstacle, and finally it gets reflected, and that's how it reaches the receiving antenna. Now let's learn how the communication over short distance and communication over long distance takes place. Now, earlier, how do you think the communication takes place? Communication means receiving and sending data or processing the information between various entities. For example, if you want to connect this speaker to the laptop, it should be connected with the help of cable or wire. Or if you want to use this headphone, then again you should connect this headphone to the laptop using this cable or wire. These days, in order to connect 2 or more devices, we don't use cable or wire. We call it as wireless communication. Communication among devices without wire, without using a wire. So we call it as wireless communication. For example, instead of using this speaker with a cable, you can use wireless speaker, the speaker which does not use wire. And similarly, instead of using this headphone, you can use an earphone without wire. So wireless communication is defined as a communication without using wire and cables. Instead of wires and cables, it uses electromagnetic wave. For a communication over a short distance, electromagnetic waves like microwave and infrared radiations are used. Bluetooth is one example of communication over short distances. So Bluetooth is the wireless communication which is used for transferring data like images, audio and video using microwaves. Now microwave, it is widely used in mobile earphones so that we can call and listen to the music without placing the mobile on our ear. So this is how the Bluetooth works between the devices. But the condition here is the distance between two devices should be 10 meters in order to use Bluetooth wireless communication. The next type of communication over short distance is Wi-Fi. It is the most extensive wireless communication which is similar to the Bluetooth, and it also uses microwaves. So for wireless communication, the distance between the devices should be 100 meters. Did you understand? Great. If you have understood, then what are the differences between Bluetooth and Wi-Fi? Now you have seen that both Bluetooth and Wi-Fi uses microwave and both are a communication over short distances. Now if you have understood what is Wi-Fi and what is Bluetooth, then can you please tell me the differences between Bluetooth and Wi-Fi? What could be the difference? Yes, the one thing is the distances between devices. In order to use Bluetooth, the distance between two devices should be 10 meters. Whereas in order to use Wi-Fi, the distance should be 100 meters. Now, in order to use Bluetooth, the Bluetooth can connect to only one device. For example, if I want to connect this Bluetooth speaker to another mobile phone, then first I have to disconnect this Bluetooth connection with the laptop. Then only I'll get to connect this Bluetooth speaker to another devices. Whereas Wi-Fi wireless connection, it can connect to various devices at one go. So these are the differences between Bluetooth and Wi-Fi. The next topic we have is communication over long distance. So for a communication over long distance, radio waves are used as it undergo diffraction while traveling. Now, what do you mean by diffraction? Diffraction is defined as the process of bending and spreading of waves passing through the gaps and edges of obstacles. As explained earlier, as the radio wave travels from one place to another place, it will come across obstacles. And when it strikes on the obstacles, then it will result in bending and spreading of waves in other parts of the places. Now, the diffraction of this radio wave will be more if the gap of the obstacles is equal to the wavelength of radio wave. The other reason why radio wave is used for a communication over long distance is radio wave gets reflected from the charged layer of atmosphere, which is known as the ionosphere. Therefore, the reflected signals can cover a larger area. Now, how is it possible to make a call to your relatives residing in other part of Bhutan? For example, currently you're at Thimphu. Now, you can talk to your parents, friends, cousins or any other relatives who are placed in other part of Bhutan, like yes, Dampu, Galefu, Hlensi, Tashikang and yes, other parts of Bhutan. Now, as you call your parents or relatives using your mobile phone, your audio is taken by the microphone in your mobile phone. And that microphone, it converts the audio to electromagnetic wave. This electromagnetic wave is fed into the antenna which is there in your mobile phone. So from that antenna, the electromagnetic wave in the form of signal is received by the antenna which is fixed on the mobile tower. So from that antenna of a mobile tower, through air propagation or sky propagation or ground wave propagation, it is sent to other tower which is stationed in other part of Bhutan. And from that tower, it is again, that electromagnetic wave in the form of signal is given to the receiver's mobile phone antenna. And that's how you can call, video call, send images to other parts, to your cousins and your parents, relatives who are at other part of Bhutan. This is how the communication is done within Bhutan. Now, you can also talk or video call or exchange messages with your cousins who are there in Australia. Yes, not only Australia, you can also contact with the people who are there in other part of the world like Canada, United States of America, yes, Nepal, Delhi, yes, so on and so forth. So this communications was not possible through electromagnetic wave, because the communication through electromagnetic wave are done in two ways. The waves are propagated through sky or through ground. And this sky wave propagation and ground wave propagation were limited to certain extent. It cannot communicate beyond certain limits. And in order to overcome these limitations, satellite communication is introduced. So what do you mean by satellite? Satellite is the small object that revolves around the large object in the orbit. Now, for example, moon, it revolves around the earth. So moon becomes the natural satellite of earth. We can also have an artificial satellite. Soviet Union introduced the first artificial satellite of the world in the year 1957 named Sputnik 1. After 18 years, India also launched its artificial satellite named Aryabhata in the year 1975. Now, do you remember our country could finally launch an artificial satellite? Do you remember in which year and the month and date as well? Yes, it was launched in the year 2018 on 29th of June. An artificial satellite of Bhutan named Bhutan 1 was developed by 4 young Bhutanese space engineers. Now let's learn how the satellite communication works. Satellite communication. The communication between two stations of the Earth with the help of satellite is known as satellite communication. Now, let's take this as Earth Station 1. So, if this is Station 1 of Earth, okay, so if this is Station 1, Earth Station 1, this Station 1, the antenna of Station 1 will collect all the informations from respective studios or other stations, and this antenna will convert the informations to signal. And this signals in the form of electromagnetic wave is fed into the satellite. That's okay. It will feed into the satellite through the upward channel known as upward link. So this satellite, it consists of transponder. So this transponder will convert, it will increase the frequency and amplitude of the signal received from Earth. And after increasing the frequency and amplitude, it will give back to the other part of station, that is Earth Station 2. Okay, that is Station 2. Okay, that is the Station 2. So through the downward channel known as downward link. Downward link. We also call it as D-link. So the frequency with which the transmitter transmits the information from ground to satellite is known as upward frequency. Upward frequency. And the frequency with which the satellite resends the signal to other part of the station is known as downward frequency. Downlink frequency, sorry, downlink frequency. Here also it is uplink frequency, sorry, uplink frequency. Okay. Antenna of the tower in Station 2 will further convert the signal and it will transmit to other devices in order to receive the information. So did you understand? Did I make it clear? Great. If you have understood, then I have questions for you. Assessment question. Question number 1. Which electromagnetic wave do humans use the most? Question number 2. What waves are used in cellular phones like iPhones, mobile units and smartphones? Write the negative impact of these waves on human health. Question number 3. Write the advantage of satellite communication over wave communication. Lastly, what are some of the impact of modern communication in our socio-economic life? Thank you for watching and see you in next lesson.